Hi, welcome back to Science 1206, the motion unit. I'm Miss Ludwell, and in this video, we'll discuss how to calculate speed. Let's get started. Let's look at an example of calculating average speed. A cat walked north 4 meters in 2 seconds, then turned around and walked south 8 meters in 2 seconds. What is the average speed of the cat? The equation for average speed is total distance traveled over total time taken. So for our total distance, we have 4 meters plus 8 meters, and our time, we have 2 seconds plus 2 seconds. So we have a distance of 12 meters divided by a time of 4 seconds, which gives us 3 meters per second. Notice that I kept the correct number of significant digits here. When I added, I kept the number of decimal places the same as the least number of decimal places in my problem. And when I divided, I kept the number of significant digits the same as the least number of significant digits in the problem. So in this problem, we calculated the average speed of the cat to be 3 meters per second. Remember that speed is a scalar quantity, so it has magnitude only. We do not need to consider the direction when we calculate speed. Let's look at another example. A dog jogs east 10 meters in 3 seconds, then turns around and sprints west for 15 meters in a time of 2 seconds. What is the average speed of the dog? The equation for average speed is total distance traveled divided by total time taken. We have a distance of 10 meters plus a distance of 15 meters divided by a time of 3 seconds plus a time of 2 seconds. This gives us 25 meters divided by 5 seconds. And when we divide that, we get 5 meters per second. And we were careful with our significant digits. The average speed of the dog was 5 meters per second. Remember that speed is a scalar quantity, so it has magnitude only. We do not need to consider the direction when calculating speed. Now it's time for you to do some speed practice problems. Pause this instructional video and grab a pencil and some paper, or open up a blank document on your electronic device. Number your paper or document from 1 to 3, leaving space for workings, and then create a separate column numbered 1 to 5. As each problem in the tables on the next slides are revealed, write down your answer. We will then review the correct answers one by one. After numbering your paper or document, please resume this instructional video. Our first problem, finding the average speed, is a dog runs east for 6.0 meters in 3.0 seconds, then changes direction and runs west for 12.0 meters in 4.0 seconds. What is the average speed of the dog? Pause this video while you calculate your answer, and then resume it, and we'll review the answer together. So the formula for average speed is total distance traveled divided by total time taken. The total distance traveled here was 18.0 meters. When we added 6.0 meters plus 12.0 meters, we noticed that both numbers had 1 decimal place, so we kept 1 in our answer. And our time, we had 3 seconds plus 4 seconds gave us 7. Then we divided those numbers, and our answer is 2.6 meters per second, because we have the least number of significant figures as what is in the problem. Let's try another one. A horse gallops 20.0 meters forward in 4.0 seconds, then trots back 10.0 meters in 6.0 seconds. What is the average speed of the horse? The formula for average speed is total distance traveled divided by total time taken. The total distance the horse traveled was 20.0 meters plus 10.0 meters gave us 30.0 meters. The total time it took the horse was 4.0 seconds plus 6.0 seconds, giving us 10.0 seconds. When we divided those numbers, we got 3.00 meters per second. Notice that in our problem, we had 3 significant digits on top and 3 on bottom, so our answer also has 3 significant digits. Let's try one more problem. A biker rides 30 meters east for 1.0 minute, then rides west for 15 meters in 3.0 seconds. What is the biker's average speed? Notice that we have two different units for time. We have minutes and seconds. So the first thing you'll need to do is to convert your time so that you have the same units for time. Let's look at the answer. So our formula for speed is total distance traveled divided by total time taken. Our total distance was 30 meters plus 15 meters gives us 45 meters. For our time, 1 minute is equal to 60 seconds plus 3 seconds. That gives us 63.0 seconds. When we divide these, we get 0.71 meters per second. And we kept our significant digits to the least number of significant digits in the problem, which was 2. Next, let's look at the definition of instantaneous speed. Instantaneous speed is the speed of an object at a specific moment in time. Instantaneous speed differs from average speed. Recall that average speed is the total distance traveled divided by the total time taken. If you look at your speedometer while driving, it shows your speed at that exact moment. That is your instantaneous speed. Police radar guns also measure the instantaneous speed of a vehicle. Next, let's try and identify the description of speed and then what type of speed is it? Is it average speed being described, constant speed, or instantaneous speed? So pause the video while you have a chance to write down your answer, and then we'll review the answer together. Our first description says, a highway speed camera captures a car's speed as 90 kilometers per hour at a certain moment. What type of speed is this? This is instantaneous speed. Instantaneous speed is the speed at an exact or certain moment. Number 2, it says a truck on cruise control maintains a steady speed of 70 kilometers per hour as it travels across a flat highway. That's constant speed. The truck has cruise control on and it's maintaining the same speed of 70 kilometers per hour. The speed is not fluctuating. Number 3, the speed a horse ran during an entire race was 29 kilometers per hour. That's average speed. The horse ran different speeds at different points in the race. The speed over the entire race would be the total distance divided by the total time. Number 4, a radar gun records a motorist traveling at 130 kilometers per hour. That one's instantaneous speed. The radar gun's taking the speed at that exact instant. And last, the speed of a cyclist on a 30-kilometer course is determined to be 15 kilometers per hour. This is average speed because the cyclist's speed is going to change over the course. This number comes from the total distance divided by the total time. Now it's time to continue to the next video. Before you do, pause for a half-minute recharge. Rise, reach, and stretch before you move on to the next video.